Hey, good morning, friends. Today I want to discuss with you about the different parts of the DC generator. As I discussed in my previous lecture, that we are going to deliver the different parts of the DC generator. Yeah. So in the DC generator, there are having the two systems. First is that the field system, and the another system is the armature system. So field systems, in field system there are having the certain parts available for the DC generator. Is that first is as the magnetic frame or the yoke, the outer body, which we can say that the barni je body je with the outer body, that is known as the magnetic frame or yoke. The second one is that the pole core. It is the main important part of the DC machines, the pole core and pole shoe. Then after, the third is that the field winding. There are having the two windings available in the DC generator. First is the field winding, and another is the armature winding. The field winding is placed on the pole core. Okay. Now it is the that all these parts are the available in the field system. But in the case of the armature systems, the parts available is that the armature core. The second one is that in the slots of the armature core, the armature winding is also available. Okay. Now the commutator, as I discussed in our previous lecture, that the main function of the commutator is to convert the AC EMF into the DC EMF. So the commutator is also the parts of the armature system. Then after, the shafts and brush. So all these are the parts of DC generators. So now I want to discuss individually about the function of each parts of the DC generator. So magnetic frame is the outer body. The main function of the magnetic frame or the yoke to protect all the inner parts of the DC generator. So that is the main function. Also, it holds the pole core. So that is the main function of the outer body, magnetic frame or yoke. Now the second one, the important part is that the pole core. The pole core, it is like this. This is the pole core material. It is made from the silicon steel material, and it's a very thin stampings of silicon steel material. Okay. Now this pole core, like this, that is known as the pole core. All such types of stampings are laminated to reduce the losses. There are having the two types of the losses available in the pole core. One is that the hysteresis losses, and another is the eddy current losses. To reduce the hysteresis losses, the material is known as the silicon steel material, and to reduce the eddy current losses, all the laminations are provided on the pole core. Okay, laminations are provided to reduce the eddy current losses. And the field winding is located on the body of the pole core, and the DC supply is given to the field winding. So whenever the DC supply is given to the pole core, the poles are magnetized, and whenever the poles are magnetized, the magnetic field is produced, and the magnetic field is spread in the air gap between the armature core and between the pole core. So that it is known as the pole shoe. It is the spread with the help of this pole shoe. So it is the core. It is made from the silicon steel material, and now the armature core. So what is armature core? The armature core is like this. There are having the slots are available on the armature core. It is also made from the silicon steel materials, and to reduce the hysteresis losses, it is made from the silicon steel material, and to reduce the hysteresis losses, all the cores are laminated. So and the windings and the winding, the name is the armature winding, is placed in this slots, in this place. So whenever the prime mover is rotated, with the help of the prime mover, armature core is rotated, and when the armature core is rotated, its conductor is also rotated, and this conductor cuts the magnetic field which is produced with the help of this pole core. When the field winding is available on this pole core, and when the DC supply is given to this pole core, the DC supply is given to the field winding, the pole is magnetized, and magnetized at that time the magnetic field is produced. So as I discussed, to produce the EMF, there are having the two requirements: the magnetic field, and the another requirement is the conductor, the presence of the conductor, and the third is the requirement of this, that the relative movement between the magnetic field and the armature core, armature winding. Okay, so when armature winding is placed in the slots, this is the rotating part of the DC generator, and this armature core is driven by with the help of the prime mover. So when it is driven, the conductor is also rotated, and when the conductor rotated, it cuts the magnetic field, which is spread into the air gap. And whenever the conductor cuts the magnetic field, as per the Faraday's laws of electromagnetic induction, EMF is generated in the armature winding. And this EMF is in the form of AC, and with the help of commutator, this is the commutator, and with the help of the commutator, it is converted into DC. It is converted into DC. Okay, thank you.